In this video, I will show you how to find the resultant vector when you have two or more vectors that are acting together, even when the direction is not simply north, south, east, or west. I will be using this four-step process and this graphic organizer. An airplane flies in a direction of north 10 degrees west at a speed of 280 miles per hour. The plane encounters a wind that is blowing at a speed of 50 miles per hour in the direction east 40 degrees north. Find the plane's actual speed and direction. Let's set up our chart. Let's label the chart. So we have two vectors. We have the plane and we have the wind. And then we want to find the resultant. In the first row, we will record the magnitude and direction for each vector. And in the second row, we will record the component form, x comma y. So, as the chart suggests, step one is determine the magnitude and direction for each vector. Please keep in mind that this theta has to be the direction measured from the positive x-axis. So we will need to convert these directions into a single angle measured from the positive x-axis. But first, the easy part, the magnitude, r. A plane flies in this direction at a speed of 280 miles per hour. So guess what? The 280 miles per hour, that's the magnitude. The wind is blowing at a speed of 50 miles per hour. That's the magnitude. Okay, now we need to record the direction of each of these vectors. So the plane flies in a direction north 10 degrees west. Let's convert that to an angle measured from the positive x-axis. When a direction is given in this form, north 10 degrees west, the north means start by facing north and then turn 10 degrees in the direction of west. So we're going to start at north and then we're going to turn 10 degrees in the direction of west. So if we do that, the vector will be in this position, where this angle is 10 degrees. So we need to convert this to an angle that is measured from the positive x-axis like this. So, had we stopped at north, that would have been 90 degrees. We call this angle theta, by the way. And this angle theta should equal 90 degrees plus the extra 10 degrees that we went past north. So 90 plus 10 degrees, so obviously the direction as measured from the positive x-axis is 100 degrees. So that is what we will record for the direction of the plane on this chart. 100 degrees. Let's do the same thing for the wind. What did they say about the wind? Okay, the plane encounters a wind that is blowing at a speed of 50 miles per hour in the direction of east 40 degrees north. That's the wind. Okay, so they said east 40 degrees north. So this type of direction means start at east and then turn 40 degrees towards the north. So if I start at east and I turn 40 degrees towards the north, then my vector will be here. and this angle is the 40 degrees. Now, we need an angle that is measured from the positive x-axis, but as you can see, if I measure this from the positive x-axis, that's what I already have, 40 degrees. So I don't need to change this to any other number. I don't need to add 90 or anything like that. I can just record the 40 degrees as it is. Okay, so look what we've done. We found the magnitude and direction for both vectors. That's step 1 complete. Step 2, convert the magnitude and direction to component form using the little formula r cosine theta, r sine theta. So let's do that for the plane. We need component form. We are thinking r cosine theta. In this case, that will be 280 cosine 100. And then r sine theta. So that will be 280 sine 100. We can use a calculator to evaluate this. Boom, this is what you get. So that's negative 48.62 and 275.75. I forgot what it was, 75. Okay, that's the component form for the wind vector. For the plane. So now let's find the component form for the wind. Again, we're doing r cosine theta, so that would be 50 cosine 40, and we are doing r sine theta, so that will be 50 sine 40. Calculator. Kabam. So that's 38.30. And 32.14. So here we have the component form for both vectors. So that was step 2. Step 3 is to add the vectors to find the resultant vector in component form. So let's go ahead and add these vectors together. So we're just going to add the corresponding components. So negative 48.62 plus 38.30. That's negative 10.32. Now let's add the vertical components. 275.75 plus 32.14. That is 307.89. So that is it for step 3. We have added the vectors, and now we have the resultant vector in component form. Now it's time for the 4th and final step. Determine the magnitude and direction of the resultant vector. So we need to take this and find the magnitude and direction of it. So magnitude we will just use the magnitude formula. Negative 10.32 squared plus 307.89 squared. And take the square root of all that. Calculator. That's 308.06. Let's go ahead and record that here. So 308.06. And this is miles per hour. So we found the magnitude. Now let's find the direction. Okay, for the direction, it is helpful to use a compass rose style diagram. So notice that this vector goes to the left and up, or west and north. So that puts us in the second quadrant. So go ahead and draw a vector extending into the second quadrant. Now make a triangle out of it. Including the reference angle R. So because this is west 10.32, I'm going to put my 10.32 right here. And because this is north 307.89, that goes here. Now I can find the measure of angle R using tangent, because the tangent of angle R should equal 307.89 over 10.32. I'm ignoring the negative sign because I just want the positive value of the reference angle. So I can find the reference angle by doing the inverse tangent of 307.89 over 10.32. Calculator. I am getting 88.08 degrees for my reference angle. Now, remember, for the chart, we want this angle theta that is measured from the positive x-axis counterclockwise. So theta should be 180 degrees minus this reference angle, 88.08. We were on our way to 180 degrees, but we had to stop short by the value of R. So the direction of our resultant vector is 91.92 degrees. Let's go ahead and record that on our chart. 91.92 degrees. So there we have the magnitude and direction. Now, sometimes this is the final answer. In this case, we have to do one more step because there are many ways of recording direction, and look at how they're giving us direction. They were not giving us directions just as an angle measured from the positive x-axis. They're using this form, east 40 degrees north, that type of thing. So we need to write that type of direction for our final answer. So I'm going to make another version of this answer. The magnitude's not going to change, so I'm just going to recopy my 308.06 miles per hour. But I'm going to try to rewrite this direction using the same type of notation they used in the problem. Okay, so since I already have the measure of angle R, the 88.08 degrees, I'm going to use that. So I could think of the position of this vector as starting from west. Let's see, let me use green. Imagine that we start from west and then we turn 88.08 degrees towards the north. Again, we started at west and then we turned 88.08 degrees. Okay, that's the measure of R. And that's in the direction of north. So this would be a way of saying the direction using the type of notation that they gave us in the original problem. So I'm just going to record this for my final answer. So there you go. Let's go ahead and do one more problem on this video. Joe and Sally hiked 3.75 kilometers to a lake located at a bearing of 215 degrees from their campsite. Then they hiked to the nature center, which was 5.6 kilometers at a bearing of 325 degrees from the lake. Where is the nature center in relation to their campsite? That is, what is the distance and bearing to the nature center from their campsite? Before we do the formal solution to this vector problem, let me just give you the big picture. So they are starting out at their campsite, all right? Pretend this is a tent, so this represents their campsite. And they travel 3.75 kilometers to a lake at a bearing of 215 degrees. Now, bearing is a way of measuring direction where you start at north and you go clockwise. So, for example, a bearing of 200 degrees would be like this. You would have to start from north and go around like this. So far, I'm at a bearing of 180 degrees, so a little bit past that. So a bearing of 200 degrees would be here in the third quadrant. Okay, so that's what they mean by bearing. So getting back to the big picture, they're traveling from their campsite to a lake at a bearing of 215 degrees. Okay, so if the bearing is 215 degrees, then measuring from north and going clockwise. Okay, so it's like this. So far that's 90 degrees. 180 degrees. If I went all the way around to west, that would be 270 degrees. So we are definitely talking about a vector that is in the third quadrant. So we're definitely talking about a third quadrant vector. Okay, so here is a bearing of 215 degrees. Now, then, so they hike to a lake. So here's my lake. Okay, and that distance was 3.75. So we have 3.75 kilometers. Now, from there they hiked to a nature center, 5.6 kilometers at a bearing of 325 degrees. So a bearing of 325 degrees, so I'm going to need an XY axis, so I can do my bearing, 325 degrees, starting from north, all right, 325 degrees would be all the way around. Okay, and almost back to the start, because 360 degrees would be all the way back. So we will definitely be here in the second quadrant for this guy. Okay, and this is a longer distance of 5.6 kilometers. And so then you arrive at this nature center. So here's a flower to represent the nature center. Okay? So the question is, what is the distance and bearing to the nature center from their campsite? Okay, so we are looking for the resultant vector from the nature center back to their campsite. And we want the magnitude and the bearing. So that's the big picture of what we're actually doing. Now I'm going to go back and do the formal vector process. We can organize our work like this. We will have one vector representing the travel from the camp to the lake, and we'll have another vector representing the travel from the lake to the nature center, and then we'll have the resultant vector, which is the trip from the camp all the way to the nature center. I had that backwards at first because we're going camp to lake, lake to nature center, and then camp to nature center, the beginning all the way to the end. That makes sense as the resultant vector. It's time to use my special 4-step process for finding the resultant vector. Step 1, determine the magnitude and direction for each vector. So magnitude and direction, r and theta. So from the camp to the lake, the magnitude of that leg of the trip was 3.75 kilometers. So that's the magnitude, 3.75 kilometers. Now we need the direction. So they gave us the direction as a bearing of 215 degrees. Now when you see the word bearing, you know that you are talking about an angle that starts at north and is measured clockwise around the compass. So if you start at north and move 215 degrees, so far I've gone 90 degrees, and now I've gone 180 degrees. If I went all the way to here, that would be a bearing of 270 degrees. But my bearing is 215, so that would be too far. That lets me know that the vector is here in the third quadrant. So I'm going to go ahead and draw my vector into the third quadrant, and I will finish my bearing angle. Okay, so this is what is meant by a bearing of 215 degrees. Now, we need to convert this to an angle that is measured counterclockwise from the positive x-axis. So if I start at east and measure this way, this is the angle that I need for this chart. So the question is, how many degrees is that? How do I calculate that? Let's figure out the measure of this reference angle right here. Now, 215 degrees was on its way to being 270, but it stopped short. So what's the difference between 270 and 215? If I do 270 minus the 215, that should give me the angle in between. Now look back at the green angle theta that I'm trying to calculate. As I arrive at west, that's 180 degrees so far, so it's going to be 180 degrees plus the extra 55 degrees of the reference angle. 180 plus 55. So 180 plus 55, that's 235 degrees. All right, that's the angle that we need for the chart. 235 degrees. Okay, so that's the magnitude and the direction of the trip from the camp to the lake. Now, another vector will be the trip from the lake to the nature center. I need the magnitude and the direction. So let's see, from the lake to the nature center. Okay, they hiked to the nature center. This was 5.6 kilometers. So that is the magnitude of this trip is 5.6 kilometers. Now I need the direction. So I'm looking for what they have to say about the bearing. The bearing is 325 degrees. Again, bearing is measured clockwise starting at north. So 325 degrees will look like this. There's 90 degrees, 180 degrees, 270 degrees, and 325 degrees puts me into the second quadrant. So I'm going to go ahead and draw my vector into the second quadrant. Okay, so this purple angle here is 325 degrees. That's my bearing. Now what I need is this green angle, theta, measured counterclockwise from the positive x-axis. This is what I need. So again, an easy way to find this would be to start with the reference angle. Let's quickly figure out what the reference angle is, which is right here. This reference angle is the difference between 270 and the 325. So let's do that. 325 minus 270. Okay. Oh, look, 55. Interesting. So the reference angle is 55 degrees again. Okay, so the angle theta that we need, the green direction measured from the positive x-axis, is going to be 180 minus 55. So that's 125. And this is the direction angle that we need for the chart. All right, so we have now completed step 1. We have determined the magnitude and direction for each vector. Step 2, we are going to convert the magnitude and direction to component form, x, y, using this little formula, r cosine theta, r sine theta. Okay, so for this first vector, r cosine theta would simply be 3.75 cosine 235, and r sine theta would be 3.75 sine 235. Let's put this in the calculator. So here it is. That gives us negative 2.15 comma negative 3.07. Alright, so that's the component form for the vector from camp to lake. Now let's turn the vector from lake to nature center into component form. Again, r cosine theta, comma, r sine theta. So that's going to be 5.6 cosine 125, comma, 5.6 sine 125. Calculator. So we get negative 3.21 and 4.59. So boom, there we go. Component form, lake to nature center. And that is the end of step 2. We now converted the magnitude and direction into component form for both vectors. Step 3, add the vectors to find the resultant in component form. So I'm just going to add these vectors together by adding the corresponding components. And that's going to give me the resultant vector here. I'll just do that off camera. I am getting negative 5.36, comma 1.52. That is the resultant vector in component form. So that's it for the third step. That just leaves the fourth and final step: determine the magnitude and direction of the resultant vector. So basically now I just need to complete this box. So I'm going to take this component form and calculate the magnitude and the direction. So let's start with the magnitude. We can just use the magnitude formula to find the magnitude. So that's going to be negative 5.36 squared plus 1.52 squared, and the square root of all that. So that's 5.57. So I will record the magnitude here. So 5.57 kilometers. So far I know that the distance from the camp to the nature center is 5.57 kilometers. Now I need to know the direction. Okay, so let's work on that direction. So again, using the component form, notice that this is left and up, or if you want, west and north. Either way you look at it, this is in the second quadrant. Alright, so I'm just going to draw myself a vector here in the second quadrant. And you know what? I think I will go ahead and make a triangle out of this. Okay, because it is left 5.36, the 5.36 goes here. Because it is up 1.52, the 1.52 goes here. Let us set about finding this reference angle. We know that the tangent of the reference angle R will be 1.52 over negative 5.36. Now I'm going to ignore the negative sign because really I just want the positive value of angle R. So angle R should equal the inverse tangent of 1.52 over 5.36. So calculator. So this reference angle is 15.83 degrees. Now, however, on the chart, I need the angle that's measured from the positive x-axis. So I will call that theta, and that should be 180 degrees minus the size of angle R. So minus 15.83. So the direction that we need for the chart will be 164.17 degrees. Let's go ahead and record that on the chart. Now, that's basically the answer, and sometimes this would be the final answer because we have the magnitude and direction of the resultant vector, the distance, the displacement from the camp to the nature center. However, this is not the final answer because of one thing. The way the directions were given were all bearings. They gave us a bearing of 215 degrees, a bearing of 325 degrees. So we need to record this direction as a bearing. And in fact, even the way they specifically asked the question, they said, what is the bearing to the nature center from their campsite? So we need the bearing. So let's look back at our diagram and think about bearing. Bearing is measured clockwise, starting from north. So if I start measuring from north, I'm going to go all the way around like this until I get to here. So I need to know what that angle is. This green angle that I just drew will be the bearing. So I know that I went 90, 180, 270 degrees. At west, I had a bearing of 270 degrees. But I went a little bit further by the amount r. So I went 270 plus this reference angle. So my bearing should be 270 plus the reference angle, which was 15.83. So that's why my bearing is 285.83. So I'm going to go ahead and record that on my chart as well. So it's really another way of writing the answer, but this is the way that they're asking us to write it. So I like to keep my magnitude and direction together, so I'm going to re-copy the magnitude. So I'm going to say 5.57 kilometers, and bearing, for bearing you have to use the word bearing, okay, and bearing 285.83 degrees. So this is the final answer. Let's put a box around it. Boom! Hey guys, that's going to do it for this video. Go ahead and click over here to watch the next video, and click over here to subscribe. That way you'll get every new video delivered right to your home screen.